All right, 7.5 is going to deal with the idea of graphing a tangent, a cotangent, a secant, and a cosecant. Today, we're only going to focus on graphing the tangent and the cotangent, okay? We'll start with those two. They're very, very similar, okay? And then tomorrow we'll go back to secant and cosecant, which will be a nice review of sine and cosine because it involves those graphs, all right? Understand that the cotangent and the tangent are going to have different x values compared to the sine and cosine. All right, so if we go to make a chart, so if you liked making the chart yesterday for your quiz and for some of your homework examples, we can still do that, and we're going to do it exactly the same way. It's just we're going to start with new x values, okay? All right, so what you see here is an example of how that unit circle applies to the graph. So based upon what you see on your unit circle, what would you say is tangent of 0 degrees? 0. Okay? Tangent, you should remember, is sine divided by cosine. And if this is the point 1 comma 0, 0 divided by 1, you would all agree is 0. So in terms of our unit circle, in terms of translating that into a graph, that we would be at the origin, okay? What would be tangent of 45 degrees or tangent of pi over 4? One. Why is it 1? Love it. Good job. Root 2 divided by 2, divided by root 2 divided by 2, okay? Ends up being 1. So at 45 degrees, and later on we're going to say pi over 4 instead of 45 degrees, okay? We have the point 1. That's going to be one of our essential points, okay? Now what happens when you get to pi over 2 or 90 degrees?
Not possible.
Why is it not possible?
Because you can't divide by 0.
All right, because remember that this is the point 0 comma 1. 1 divided by 0 is undefined, and so that's where this dashed line is coming into play. It's an asymptote, okay, and that's occurring at pi over 2. Okay, and then what happens is our tangent function becomes reciprocal. It just repeats itself every value of pi. So if, if I just keep going up the circle, okay, I'm going to get the same tangent curve as I would over here to the left. Okay, and then once I get to the other side of 270, I'm going to get another tangent curve. It's just going to keep being the same, all right? But there's a couple of values that we should put on this graph to help finish the graph, okay? So that we have our parent one. Working backwards, think here, what would negative pi over 4 be? What's tangent of negative pi over 4? So for you, that would be tangent of 315 degrees or tangent of 7 pi over 4 on your unit circle. What would that be?
1.
Not 1. Negative 1, because shouldn't it be a negative divided by a positive? So we're down here at negative 1. We have a point. Okay, and then what is tangent of negative pi over 2? Which is the same thing as tangent of 270 degrees or tangent of 3 pi over 2. What's tangent of negative pi over 2? Not 0. Undefined, because remember that it would be this point down here, which is 0 comma negative 1. Negative 1 divided by 0 is undefined. So we have an asymptote occurring here, and so if I were to finish our tangent curve, it looks like this. It's like an S curve. It kind of looks like our cubic function, okay? All right, so that is going to be what we're going to refer to as our parent function, and the values that you are going to need to know are going to be your negative pi over 2, your negative pi over 4 gives you a y value of negative 1, your 0, your pi over 4 gives you a y value of positive 1, and then your other asymptote is going to occur at pi over 2. So these are going to be the 5 x values that we will have to work with in our chart if we want to talk about like using the phase shift and the period change and all that stuff. Okay, with sine and cosine, remember it was 0 was the first one, pi over 2, pi, 3 pi over 2, 2 pi. So we have new values that we got to work with, okay? All right. Down at the bottom here, okay, just ask some questions that we've kind of answered a little bit already, so we'll kind of go through this quickly, okay? The first one, tangent of 0, you said occurs when theta is equal to
0, 180, 360.
0 degrees, okay, 180 degrees, which is the same thing as pi, and 360 degrees, which is 2 pi, okay? When is tangent of theta equal to 1? Say it again, Dan. 45 degrees, and remember that 45 degrees is the same thing as pi over 4. And where would be another example of that? Go ahead. 225 degrees, which is occurring at 5 pi over 4. The difference between 5 pi over 4 and 1 pi over 4 is 4 pi over 4, or pi. The reason why I'm emphasizing that, and you see it again with your 0 quantities, is notice that everything goes up by a value of pi, because the period length that we're going to talk about in a second is pi for tangent. Okay? When do you get negative 1? We already did it. What?
135.
All right, 135 degrees, which is the same thing as 3 pi over 4. And there's one that occurs in the fourth quadrant.
315.
315, 180 plus 315, 7 pi over 4. Okay? All right, so back a couple chapters ago, we talked about the idea of symmetry with our graphs. We talked about symmetry across the x-axis, symmetry across the y-axis, and symmetry across the origin. If I were to ask what type of symmetry a tangent curve has, what would you say? Is it symmetric about the y-axis? Can you fold it across the y-axis and it looks the same? Can you fold it across the x-axis? No. What about the origin? Yes. If you were to fold it across the line y equal to x, it'll end up being the same. So it is symmetric about the origin. You don't necessarily need to remember that. It's just a good way of just reviewing something that we've talked about before. All right, it has a break at negative pi over 2, because that's where our asymptote is going to occur, and it has another break at pi over 2. I'm focusing on these two because these are going to be the two that we are going to use with our parent function. Okay, and this is where the function is undefined, and that's why they are called asymptotes. All right, your tangent graph does not have a maximum or minimum. If I were to ask what the range of a tangent curve is, noticing that there is an arrow pointing up and there's an arrow pointing down. There are no breaks in between. Love it. Negative infinity to infinity. Perfect. Okay? And then the period length. If from one... and you can see it right here in this graph. If one asymptote's at negative pi over 2 and the other one's at positive pi over 2, what's the distance between those two? Pi. So therefore, our period length for tangent, and it's going to be true for cotangent, is going to be a value of pi. What was our period length for sine and cosine? 2 pi. So it got cut in half, okay? But the way that you find your period length, okay, when we get into our graphing, okay, it will still be pi divided by b. For sine and cosine, it was 2 pi divided by b. So you still divide by b to find your period length, a new one, okay? All right, page 2. Let's talk about graphing. All right, for the very first one, because there's only one thing that is occurring here, what I am going to do is I am going to start by just simply graphing y equal the tangent of theta. I'm going to graph the parent function so that you understand the 5 pieces that I'm looking for. And then what we'll do is we'll come back and we will graph on the same graph the 3 tangent, okay? So, number 1, we need to know that we have an asymptote occurring at x equal to negative pi over 2. We have another asymptote occurring at positive pi over 2. Tangent of 0 is 0, so we're going to have a point at the origin. The other 2 points that I need you to be able to find would be what's half the distance from 0 to pi over 2. Pi over 4. And the reason why I'm asking is because later on, I might say, what's half the distance from 0 to pi over 12? What's half the distance from 0 to pi over 6? So on and so forth, okay? All you simply have to do in order to find this number is double the denominator. All the time, okay? All right, so then over here, we should have negative pi over 4. All right, we already did this on the front. We said that at pi over 4, you have a y value of 1, and at negative pi over 4, you have a y value of negative 1. So our parent tangent curve looks like this. Okay? All right, so how does the 3 affect that? What's our 3 known as?
Doesn't it change the amplitude value, so instead of, well, not amplitude, but,
No, you are correct. It's our amplitude value. So how is that going to affect our graph?
so instead of pi over 4, or pi over 4, 1, it's gonna be pi over 4, 3. It's gonna make it a steeper curve.
Okay, so he says that this point is now going to shift up to the 3. And so therefore, what about the point on the left?
It's gonna go down 2 more to the negative 3, yeah.
Okay, and it'll still pass through the origin, and so this is what 3 tangent of theta looks like. Okay, so remember our 3 is our amplitude, and if you think back to sine and cosine, it stretched the graph up. Okay, it made our curves, our hills and our valleys steeper. Okay, and it's doing the same thing now. If you want to look at it another way, think about order of operations. If I were to plug pi over 4 in to theta, I would do tangent of pi over 4 first and get 1. Then I would multiply by 3 and get 3, and so the y value is the one that's changing. Okay? Questions there? Now, that's one way to graph all the time, is you can always graph your parent function and then change it. But sometimes you don't necessarily have to, and we'll see if we can go directly to our new graph without doing that. Okay? So, there's 2 things that are occurring here. So what do you think the negative is going to do to the graph? It's going to flip it. So instead of it going up from left to right, it's now going to go down from left to right. And then what does that 3 represent? Is that an amplitude thing? No, what is that 3 representing? Our period change. So think about this. We said on the front side, the way that you find the length of your new period is that we take pi and divide by b, or in this case, pi divided by 3. So what that tells us is from one asymptote all the way to the other asymptote is a value of pi over 3. So half of our graph is going to be to the left of the y-axis, half is going to be to the right. So I need to take this period length of pi over 3, and I need to cut it in half. So what is half of pi over 3? Pi over 6. So that tells me that I now have an asymptote occurring at x equal to pi over 6, and an asymptote on the other side occurring at x equal to negative pi over 6 because of our symmetry. All right, so quick review. We took our pi, we divided by 3 because b was equal to 3. We took that value and we cut it in half to find our two asymptotes. Okay? Now, we just said a second ago to find these middle points, what do we do with our two asymptote numbers? Double the denominator. So what is our two new x values going to be?
Negative pi over 12 and pi over 12.
Very good. Negative pi over 12 and pi over 12. Okay, and then we still have the origin that we're going to use. And the reason why we can stay at the origin for now is because there's no vertical shift and there's no phase shift. So one of our points is going to occur at the origin. Okay? Is there an amplitude change? Is it going to go up from 1 or down from -1? No. Okay, the only thing that is going to happen is Dan already said that it is going to flip. So instead of it being pi over 12, 1, it's pi over 12, -1, and vice versa. And so now our graph does this. Question? Yep.
So you found your period length by doing pi over b, so pi over 3.
Yep.
And then how did you come up with pi over 6? You always just like double the denominator?
Just double the denominator and that'll, so basically you have to cut it in half because, like I said, half is on one side, half is on the other side. Okay? And then you basically have to double the denominator again to find the halfway points. Yes. Okay? Anybody else? Okay? Example 3. What's occurring here? You have an amplitude and a period change. Do you want to try this one on your own or talk about it again? Good talk.
Try it on your own.
Try it on your own, okay? So the very first thing that I would do, okay, is how about this? I'll just kind of let you stay one step ahead, okay? First thing I would do is figure out where your asymptotes are. So what's the length of your period? And then divide it in half. So who knows where the asymptotes are going to be? Jason?
That would be x equals negative pi over 4 and x equals pi over 4.
Okay, so x equals negative pi over 4 and x equals pi over 4. Okay? Anybody not know how to get that? Okay? So the next thing I would do is figure out where those two middle points are going to be at. Once you figure out where those two middle x values are, then think about your amplitude change and where those y values are going to be for those new x values. So what are the new x values going to be in the middle? Between the y-axis and the asymptote. What? Negative pi over 8 and pi over 8. And where are the y values going to be at? So at 4 and at -4. Okay, so we have a stretch of our tangent. Not too bad. Okay, so think about this. We focused on the period value first, then we did the amplitude. We kind of did that last. Okay, when we did sine and cosine, we kind of focused on our amplitude first, and then we went to period. So there's a subtle switch here. Okay? Any questions on 3 before we go to 4? All right, so number 4, you have a little bit of everything occurring. So this is going to be the example which I'm going to teach the idea of the chart, if you like the idea of the chart. Okay? First thing, though, is we should always factor and rewrite it so that we know what A, B, C, and D are. So I would rewrite this as 2 tan what? 4, parentheses, theta minus
Pi over 8.
excellent, and then -1. So I would always do the factoring first. So now you can see that you have a phase shift, okay? All right, so what we're gonna do now is I'm gonna show the chart concept, okay? So I have my chart. My original x values for tangent, though, are negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And remember that this was an asymptote, and this pi over 2 was an asymptote. Okay, so the beginning and the end are asymptotes. All right, like we did before, you are going to multiply by 1 over b. In our case, we are going to multiply by what? What's b? So we're going to multiply by 1/4. We're doing the exact same thing that we did when we did our sine and cosine. So if I multiply negative pi over 2 times 1/4, I get negative pi over 8. Negative pi over 4 times 1/4. Good. 0 times anything is 0. Then I should just get pi over 16 and pi over 8. Okay? Next, just like we did with sine and cosine, we added or subtracted our c value. So in our case, are we going to add or subtract? Add. And how much are we going to add? Not pi over 2. Pi over 8, because remember that you have to take the factored value. Okay, so we want the pi over 8. So negative pi over 8 plus pi over 8 is 0. Negative pi over 16 plus pi over 8 is? How about pi over 16? 0 plus pi over 8 is pi over 8. Pi over 16 plus pi over 8 is 3 pi over 16. And then pi over 8 plus pi over 8 is pi over 4. So these are our new values. Reminder that 0 is an asymptote. So that means that I have the y-axis is an asymptote. Our graph is not going to cross it. And then at pi over 4, I have an asymptote. Okay, so I have x equal to 0 as an asymptote and x equal to pi over 4 as an asymptote. And I would like you, like when you're doing your homework and your quiz, label your asymptotes similar to what I'm doing. I'm basically saying this line is x equal to 0, that line is x equal to pi over 4. Okay? The numbers in between the two asymptotes are the 3 that we came up with, which are pi over 16, pi over 8, and then 3 pi over 16. All right, just catching your breath. Any questions? All right, so then we've taken care of our 4 and we've taken care of our pi over 8. Now we have to take into account the negative 1 and the 2. What does the negative 1 do?
It's a shift downward. It's the negative 1 will make it, instead of starting at 0, it starts at negative 1.
Okay, so instead of our tangent curve occurring on the x-axis, it is now going to occur down 1. Okay, so we should just have this point right here is the middle of our tangent curve. Okay, now we've got the 2. What does the 2 mean? Eric?
Go down 2 from negative 1, you also go up 2 from negative 1.
Okay, so that means we're going to have 1 point at 1 and 1 point at negative 3. The 3 pi over 16 should be at the 1, and the pi over 16 should be at the negative 3. Because it's not negative, so it didn't flip, it should still be going up from left to right. Okay? Questions there? Again, just focus on doing one thing at a time. So reminder, the first thing that we did was we factored, okay? And then we focused on our period length first, okay? That gave us the middle part of the chart. And then we focused on the phase shift. Then we did the vertical shift, and then we finished with the amplitude change, okay? Questions? All right. I'm going to skip down to the very last graph on page 3, dealing with the cotangent, and we'll leave cosecant and secant for tomorrow. Okay? All right, so what I'm going to do here is I'm going to have us graph it. You already see it a little bit over here on the left, but let's just graph it by hand just so that we get the practice of it and understanding where everything is occurring. So, going back to our unit circle, okay, so that we can apply it to our graph, okay? What is cotangent of 0 if our point is 1, 0, and cotangent is now cosine over sine? It's undefined. So now, instead of having an asymptote at negative pi over 2, we now have an asymptote at x equal to 0. So just a heads up, the cotangent curve is going to be a phase shift of the tangent curve. Everything is going to shift to the right, okay, by a value of pi over 2. And then there's one other thing that's going to change, and that is the cotangent is going to be a flip, okay? All right, so then what is cotangent of pi over 2 if we have the point 0, 1? What's
No, 0.
0? 0 divided by 1 is 0. Okay, so we have this point right here. All right, and then let's do one more point over here. So what is cotangent of pi, or 180 degrees, if it's the point negative 1, 0?
Fine.
Undefined, because it's negative 1 divided by 0. So therefore, we have an asymptote occurring at pi. What would you say the period length is for cotangent? Pi. Very good. Notice the halfway point is pi over 2. So what would be our two other points? What would be halfway between 0 and pi over 2? And what is halfway between pi over 2 and pi? 3 pi over 4. We're going up by a quarter each way. Okay? All right. So now, using your unit circle, what is cotangent of pi over 4? If that is root 2 over 2, comma, root 2 over 2. What is cotangent of pi over 4? 1. So therefore, we have, at pi over 4, we have a 1. What is cotangent of 3 pi over 4, or 135 degrees, if it is the point negative root 2 over 2, comma, root 2 over 2? Negative 1. So now, notice this is why our graph got flipped for cotangent. It's going down from left to right. Whereas tangent, it went up from left to right. Okay? So when you go to do your chart, if you wanted to with your cotangent, you just have to use these new x values as opposed to the other ones. Okay? So understand that idea. Okay? And they're all based upon that unit circle. Okay? All right, so give you an option. Question 3 or question 4? Which one would you like to do? 4. Okay? Use the chart or no chart? You want to use the chart?
Is it no chart way?
You can try and do it with the no chart way. Okay? So if we are going to use the idea of the chart, okay, you have to keep in mind what are the original values for cotangent. Where's your first asymptote? 0, then pi over 4, then pi over 2, then 3 pi over 4, and then your other asymptote's going to occur at pi. So remember, 0 and pi are asymptotes right now. You are going to multiply by 1 over b. So what are we going to multiply by? 1. So everything's going to stay the same, so we can basically skip that part.
There's a negative.
Remember, that's your amplitude, so that's going to not affect, okay? All right, then we have to add or subtract our c value. Are we going to add or subtract? Subtract, and what is c equal to? Pi over 4. So what's 0 minus pi over 4? Negative pi over 4. Pi over 4 minus pi over 4. Pi over 2 minus pi over 4. 3 pi over 4 minus pi over 4. And pi minus pi over 4. Okay? So, basically, you can see, okay, based upon the chart, numbers in your chart, and from the equation, that there's a phase shift to the left. So we now have an asymptote all the way over here at x equal to negative pi over 4. Okay, we are going to have one of our points on the y-axis. We are going to have the middle of our graph occur at pi over 4. We're going to have another point occur at pi over 2. And then our other asymptote is going to occur at x equal to 3 pi over 4. All right, what does this plus 2 mean? It's a vertical shift, so that means the very middle of our cotangent curve is going to be at 2. Okay? So we've got done with the pi over 4, we're done with the 2, now we just got to focus on the negative. What does the negative mean that our cotangent curve is going to do? It's going to flip, so instead of going down, it's now going to go up. So at 0, what is going to be the y value? 1. At pi over 2, what is going to be the y value? 3. Remember, it's going to be down 1 from 2 and up 1 from 2. And now you've got your graph. Okay? So, first thing that you should always be thinking about is find your x values, similar to what we did with the sine and the cosine. Then what we do is we find the very middle of the graph, and we did that by using the vertical shift, and then focus on these 2 other points using the concept of the amplitude, okay? And that just simply means that it gets, flipped and then down 1 and up 1, okay? Questions?